So hello again, everyone. Welcome back. Nice to see y'all. Um, just hopefully go through some quick things today. Um, I don't quite have any agenda items. I know it's kind of been a little time since we've done like a session after the meeting as far as coding and chatting and stuff. That we'd be up for doing that maybe next week. If you guys are wanting to just, I don't know, we can go over some other stuff, do some coding stuff after the meeting. Just if that works for everyone. We hate to, do it today because it's like, oh man, nobody planned for it. But let's look at doing it next week. So next Wednesday after the meeting, I'll be doing that. With that, again, some quick reports. Let's see here. So we have just been working on the EM1D stuff, just getting it all finalized on my end. I've gone through and kind of reorganized it a bit internally, meaning that like I've gone through and made a bunch of the improvements that I could see as far as runtime improvements. So just going through there, work my way through the frequency domain stuff. Definitely works a little bit quicker, at least twice as fast as the frequency domain stuff was for like a lot of layers. And if it's just like a single layer stuff, it goes really fast. It's just the more layers, less of the speed up, but it's still faster. I mean, yeah, when I was like just comparing like single, I also was able to expand it back to be able to support receivers that have multiple locations, other items.
If I would be happy to test that once it's ready to get tested and to compare it maybe to some of the PyMod result, that should be fairly straightforward to do some dummy checks.
Yeah.
Just let me know and tell me which branch and.
Yeah.
And we'll have an example for a joke, because that'll help me a lot to update what I have using the old SimPEG EM1D. Is there one currently?
The structure is basically a lot more like the frequency domain code in SimPEG now. So
sounds good.
Sounds good, yeah. So basically, it's going to be a simulations. We're going to create receiver transmitters, pass it over to, and then that's it. Okay.
Yeah.
Sounds good.
Yeah. That's about all I have for now. Dieter, do you want to give an overview of like the 1D or the EM3D 1.0 stuff?
Yeah, I'm happy to talk a bit about that. You've seen I finally pushed it out, and I guess it's the same as you after Discretize. So which number was it? It just convinced me again that release often and release fast, because this one I was building up since February, and it's in the end just more painful to have big commits than just every couple of weeks one. So I'm really happy it's out, and I'm sure very soon I have to make a bug fix release, but yeah, I don't care anymore at that point. So it's all out. It's hopefully stable. There is a problem with the gradient that Sogi discovered. That's really cool. But I mean, the main point at this stage for both codes is just forward modeling. So the gradient is just something beta at best. As you've seen, these projects are finished, but I hope to improve on them, part of my new jobs. But I'm at the moment figuring out what actually will look like my new job. So I'm just in the proposal state, sort of, because there are the rough guidelines, but I'm still have a lot of say in the details what I'm going to work on in the next year. So I'm at that stage. So if anyone did use EMG3D and now is running into troubles, just give me a line, and it's all my fault, and I'm happy to help.
Well, I'm so happy to report that I haven't heard anything negative about the Discretize change. So I'm not sure how many people are using it yet, but I haven't had anybody contact me with bugs yet. So Yeah, that's good. Good that you got the 1.0 version out. It's always a big milestone.
Yeah, I think we talked about SimPEG as well. When will come the point, right? So it's still somewhere in the future, I guess, but it's coming nearer.
Yeah, it's coming near. I have a feeling it'll tough. So with the next release, the next like major or minor release, the next minor release is probably going to remove all the deprecated stuff from 13.0. That was like all the old stuff that kind of still almost worked. Like it was just put in there to make it, transition a little bit easier. But
is the goal to first have a Discretize 1.0 before a SimPEG 1.0, or?
I think Discretize is probably closer to having 1.0. The only other thing I could see adding to Discretize for 1.0 release would be like tetrahedral meshes, just to be able to support them.
Yeah.
So, but other than that, I think Discretize is pretty close. Devin, have you been able to work on any of the documentation updates for Discretize?
I'm gonna try and do some of that today. I got caught up in some other stuff in the last week, but yeah, I should move forward with that.
Okay.
I just recalled by finalizing a thing. It's one of the many things that didn't make it into the 1.0, but we discussed here before, how about having different gallery builds and documentation builds, right?
Mm-hmm.
And Tony Hallam from GeoSci.xyz, he has quite a nice setup. So he uses read to docs, but then uses GitHub Actions for the gallery, at least for the pull requests, I think, and the releases. And then you can build your gallery on read to docs and upload the artifacts and retrigger a read to docs build. And then read to docs will include that, or however you set up is. I think you're not on read to docs, but yeah, something like this might also be an option to only have the gallery build on push requests and releases or something like this.
Yeah, I kind of like the idea of splitting it up and using both of those services at the same time, so we can get a little bit more stuff done in parallel.
So that's, yeah, that would be one repo to have a bookmark on the GeoSci.xyz from Tony Hallam. He built that nicely.
Cool.
And the goal of that is just to reduce the burden on read to docs.
At the moment, read to docs has a 15-minute build limit, and I think a 400 megabyte, so it's quite low. And funnily enough, GeoSci.xyz would easily build with that, but he was just interested in how to do it, and so it can potentially grow. Whereas GitHub Actions, I think, has 8 gigs and 2 hours, or it's quite a large limit that GitHub Action has.
Yeah, and I'm just not even sure 2 hours would get us there for the gallery, all the tutorials and gallery examples that we have. Like I think 2 hours, actually 2 hours should work, because I think that's the limit that I have on the Azure pipelines right now. You can go beyond that, but right now it's like it defaults to being like 45 minutes, but you can push it. Like I just had it set as 2 hours.
2 hours, it might be completely, it's at least 2 hours. It might be much more, but I'm really not sure on that one. But it's substantially higher than read to docs, and I think it's also higher than Travis used to be. Yeah.
That's good. I don't know, Devin, do you have any other updates on stuff?
No, not really. It was mostly GIF tools related week for me. So I'm actually kind of looking where to jump back into some stuff. The documentation actually just seems like it's probably the most important thing I can work on right now, since you and Soggy are working through the EM1D.
Yeah, that's what I would bet as well.
So
hopefully it shouldn't be too much. I realize it's just a bunch of writing, so it shouldn't be too much like testing stuff.
Yeah. I mean, I'm open to a new project. I think I have some time kind of opening up. I'm kind of curious about the natural source stuff and the state of that, and Following up on the Discretize tutorials section, I don't know if you ended up finishing off all the boundary conditions stuff, and if I'm kind of ready to pick up there.
Yeah, I think it should be good soon. I was actually going through the documentation already, like the documentation again, and looking at the old examples from the galleries and like the old tutorials and stuff. And I was like, I reminded myself there was actually a decent amount of stuff in there from the, I mean, not as in depth as what you had done with the tutorials that you had made, but there was actually some decent stuff in there already about like finite volume and like how we're applying it and stuff, which is good.
Yeah, it just wasn't, it was just,
Sweet.
each one of those examples was like a contained thing. It didn't fit
Yeah.
into kind of a larger structure for
Yeah.
someone learning it. So, I mean, yeah, I read through those when I was making the stuff that that I made.
Yeah, I would say probably
the
the best thing will probably be to go through the, like, write the documentation for some of those, like some of the methods, functions, things like that. And then when you're doing like your tutorials, hopefully it should make them maybe shorter, so you can just link to functions instead of like talking about them or anything, if it happens.
Yeah, I want to do it once. I've gone through and done it, and then gotten reviews, and then things change, and then people say, "Oh, actually, this way is better. Let's redo the whole entire thing." I'm not doing that again. So
yeah, I get it. Like,
one thing I have been trying to do with the docstring stuff is wherever I can, I have been putting in examples that will demonstrate that function.
Yeah, that's perfect.
So hopefully that in itself will make some of the tutorials shorter. But yeah, unless we get a clear idea of what we want, it's a lot of time to put in to find out somebody wants it to look different. It's a very big time waste for me.
Oh no, I get it. Yeah.
Yeah, so I'll finish up with the doc strings. We'll get that happy, and I'll try and put in all the examples to show how you would execute those functions. I think that will be really useful. And then when we're happy with that, revisit the tutorials.
Yep.
So yeah, that's pretty much my plan for today, actually.
Sounds good.
Unless Diane gives me more sites for this other project.
Okay. I don't know. Anyone working on anything else they'd like to share? Tom, Thibaut, Ben?
Yeah, no, not much update on the coding part for me this week. I might just mention that I just posted on seminars that there will be a BCGS talk next week, and I could not find like an advertisement on the web, etc. So it's just by the email I received, so might be worth mentioning it. That's about it for me.
That's a bit of a last minute one. It's your old buddy Ben from Memorial, right? Medra?
Oh, Merdad? Oh yeah.
Merdad, yeah.
Nice. Yeah.
The offshoot company coming out of Collins Group at Memorial. Tetra meshes, if you guys are interested.
Cool.
I've started doing just a little bit more of virtual work, let's call it that way. Just thinking of a more general directive to be able to handle all the nonlinear, maps that we have. Because right now we kind of have implementing one directive per kind of, type of regularized nonlinear reg, or I guess the simulations are doing it themselves. But I think it would be nice to just have a general one that just cleans, the deriv only at the end of a gas Newton, and just lets the map or whatever function regenerate it in between iterations instead of having to duplicate code a lot. But yeah, it's just mental work at this point.
Okay.
Still thinking about the amplitude reg.
Yeah. Okay then. Well, I mean, I think the amplitude regularization template, it's like, as I was going through your code again, like the formulation again, I had a thought about it, and that like basically I was like had a thought being like, oh yeah, that was going to be like if I was thinking about directly translating the magnitude of a vector into like from Cartesian to spherical. Like I was like thinking about that way in terms of like how it would be regularized. And I was like, oh, I guess it probably would just be the, you know, the length of r, or the absolute value of r is like that's the magnitude of that vector, and that's what it's getting. I'm assuming that's what they're essentially boiled it down to in their the paper that you're referring to.
Yeah, but you know they kind of hacked it. They're using the amplitude in the weight term, but they haven't explicitly said like, you know, this is what we're minimizing.
Mhm.
And it becomes really hairy with the cell weights, right? Because now the mapping is also applied to the cell weights, so we're kind of doing the transformation of the weights from Cartesian to spherical as well, and that doesn't seem to converge. Maybe my derivatives are not right. I need to double check that. But. And then, you know, in the mapping, we also have, technically, we could also have wires, right? Because you could have like a vector model with a scalar model, and then you need to be able to have both the mapping. So yeah, it all needs to line up. It's not obvious. Need more time.
Cool.
So is there actually any active development right now with the potential field codes?
That's on my side. That's it. Yeah.
Yeah, I mean, I don't know how much extra work it's going to be, but while you're poking away at that, would you be able to add that equivalent source layer? You know, right, how we did with the MDRU project. I had to go in and sort of fudge around with things. So one thing I noticed was that a constant we use for stabilization of the forward problem depended on dz, which if we don't supply will break. The other thing is that the regularization had some issue with the mapping. So it sort of got confused and sort of didn't know if it was a 2D problem or a 3D problem, and I would get something breaking on the in terms of the regularization. So for this project and to do that step, I had to fudge a couple things in the code, but if you were able to do that, that could be useful. That might open it up to a bit of a larger project, because I don't know if we want to use the same simulation class for that, or if we want to say, okay, here is a like equivalent layer class, so that the how you're defining the tops and bottoms of cells is much more upfront. Because right now you're like kind of going in there and playing. So it's something to think about. I don't know if it's a lot of extra work for you or if you don't have the time, but it's something that's pretty useful.
Yeah, the equivalent source is sort of in the pipeline that we want to be able to give to our users, right? The option to do.
Yeah,
That's a good point. Yeah, I don't know if it should be its own simulation or.
I kind of think it could be its own simulation, and then you could feed in maybe a topography object, which would define the tops of your cells, and then you could feed in either a constant or another surface object to define the bottoms of your cells. Because yeah,
It would require its own simulation just to do a layer like that in that manner, because the current code would not be able to support something like that.
Yeah, and just the fact that right now, it really the way that the code works right now really should only accept a 3D mesh.
Right. But I mean, you could always just, you know, do a 3D mesh with one layer, right?
Yeah, well, we feed in a 2D mesh, and then we physically alter a property which is telling us what the tops and the bottoms.
Right. No, I understand. Like I'm thinking about two separate things here. Like that that property, yes, I would agree that it'd have to be a separate simulation, right? Because the way that the code is right now, it would not support having cells that are like slightly shifted relative to each other.
Yeah, yeah.
What I meant was that like right now you could use the 3D simulation code to do a equivalent source layer. Like, right, you could just have it, you would feed it a mesh that is 3-dimensional with only one layer, with only one cell depth. It would have to be flat, right? It would definitely have to be flat. But
Now the code you can override the Z nodes, and then your mesh can be like this. Basically, that's what we were doing, right?
Yeah. So either way, it's not straightforward unless somebody tells you about it. It's useful, and I don't know if there's any kind of time difference. There really shouldn't be, but there is maybe there is some kind of time save if you're having a 2D mesh instead of a 3D mesh with the same number of cells. I don't know if it really saves you anything.
no,
I don't think so.
not
No?
with the way you're describing it. The only time save that you ever get, like on the rectilinear type meshes, is when you can like you compute that one nodal function, right? And then you do the integral and stuff. On a rectilinear mesh, you can save it by only calculating that nodal value once for each node, or once for each node, and then summing them. That's the only thing.
If you have a 3D mesh that's one layer thick, is the regularization going to be smart enough when you're taking the derivative in the vertical direction to, I guess, either not take it into account or recognize that you're not going to be able to take a derivative in the vertical direction? I thought there was maybe going to break there. So one of the things we thought about is putting 2 layers so that the derivative in the vertical would work.
I don't think it. I mean, try it. See if it does break first. I don't know of any
Hopefully,
reason.
you should not.
I think it might break. I mean, I ended up in the position that I am now because I had to change things in the code in order to be able to do this thing anyway.
It'd be interesting to see where they broke, because like where the assumption is coming from.
Yeah.
It's like I don't like the cell difference operator shouldn't, like, that should be fine, because that works from, cells to all faces, so that should be fine.
Yeah, maybe there's we haven't covered the case for a single cell, along the dimension. I'm not sure. It should not break.
Yeah.
Yeah. Well, at least I have a branch that would show where I changed the stuff that I needed to get this to run, and I think it might make some sense.
Yeah, if you grab that branch and just PR it, so we can do a diff, right? We'll see where you have to change things. That might help us create the issue.
Yeah, I can do that.
Cool. Anyway, John, I see you're able to show up. You got anything?
Yeah, just some updates on I merged main into simulations MT. I've got it up to where I had it before, so there's just like a few tests that are in the seismic and the flow. I think they're on the examples that are just failing, so I just got to pick that out. And yeah, I've started to pick away at the tiling branch, getting that all brought up to date and looking at what tests are failing. So, other than that, yeah, just picking away at that stuff, getting that all up to date, clean up.
Cool.
I don't know if we wanted to chat about that, Joe. What I was telling you yesterday, where I had to remove that. If you have the imaginary side of the frequency domain receiver, it applies -1. It seems like when I merged it into what we did before, it was doing it twice. Yeah, I don't know. Take a look sometime, I guess. Yeah, I'll try and pick it out, and then I'll just tag you.
Okay, sounds good. Anything else anyone would like to add? I think if not, that's about it.
Easy week.
30-minute meeting. That's good. I always prefer to end early so people can move on to their other stuff.
I would have a question out of interest. So the question Neil asked about the mesh size, right? And you said that looks about okay. What the method is that resistivity?
Yeah.
And that's enough mesh boundary, let's say.
I mean, I don't know. I was just kind of eyeballing it. Like it looked a bit to be about okay.
I have absolutely no experience. That's why I'm
yeah.
asking. Yeah.
My statement was basically like, there's no reason that you should have to put the boundary any further out when you're using a curvilinear mesh than you would with the tensor mesh. Like the boundaries are handled pretty similarly to each other, and there's the curvilinear mesh certainly supports like it supports the boundaries whatever you give it. Yeah.
That's interesting. Thanks.
Okay. Well then, I guess I'll see you guys all next week.
Sounds good.
Take
Yeah.
care.
Enjoy the good
Have a
weather.
good one.
See ya.